forgot to change the subject. They asked me to give a talk on this subject at another meetup, and so I wrote it, and this was the subject. It's supposed to be testing and production, but there, I fixed it. But that is the answer, right? It is not only the answer, it's kind of an existential fact of life that we as an industry have tried our best to deny, that we all test in production. We have to, we should, and we should stop denying it. Testing in production has really gotten a bad rap. Like, you say it and people like cringe, right? It's bad. I kind of blame this guy. The meme is really funny, right? It's funny, so we share it and we're like, oh God, yeah, that's terrible. But it's wrong, it's misleading. It's a false dichotomy. It is not you can test either before production and in production. You can do both. What if I told you that, you can test the shit out of it before you ship? There's not a limit on the number of tests that you can run before or after. But we do have a very limited amount of energy and time. And what we see people doing is, like, everybody loves to tell you what not to do, right? You break something in prod, they're like, oh, you shouldn't have done that. You should have done it in staging first. Staging, I increasingly think of as this black hole for engineering time and energy. Diminishing returns, like sharply diminishing returns. What do? We try and make it match production. Oh, well, except we can't, because for security reasons and for like logistical reasons, we can't actually mirror the data. So boom, there's one like ginormous factor that you're not actually testing. Real data, real users, you're not going to have real users, so you're not going to be testing any actual concurrency. It's really just a glorified unit test. It's a glorified laptop. Staging at best is a glorified laptop, and that's not nothing. It's not nothing. I'm not encouraging you to not write and run tests. Tests are great. If you're using Docker and Jenkins or whatever, you're testing the network, which is slightly better than your laptop, but it's not a lot better than your laptop. I'm way ahead of myself. But why? So we put all this effort into our staging environments. Why is this bad? Well, it's bad because we have a limited amount of engineering time and energy and effort. And if we're putting all of this shit into like trying to harden our release before we make it live, this is a zero-sum game. That is effort that we could be sinking into guardrails, making it so that you can detect production failures and roll back from them quickly and easily, making it so that people don't make common mistakes. We have a limited, finite amount of engineering energy, and I want to encourage people to invest that in things that will have a bigger impact. The game is resiliency, right? Not never failing at anything. It's been this way forever. Like, these are facts about life, right? Why is it becoming acute? Well, let's look at what's happening in the world of systems architecture. We've gone from the humble lamp stack, which if you can get away with running a lamp stack, God bless you, don't change. Like, it's so much easier. So many people like go microservices and blah, 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 and you're like, you could run that on a couple of like fucking servers. Just do that, right? It's easy. It's easy to tread the known paths. If you can tread the known paths, do so. That one in the middle, some people here will recognize it. It is the diagram of Parsons infrastructure, circa 2015 or so. That glob in the middle is many dozens of MongoDB replica sets. There's a lot going on. A little hard to keep in our heads. But even that is out of date, right? And increasingly, the thing that you need to be keeping in your head if you're working on a distributed system looks a lot more like the national electrical grid, right? Where some problems are intensely local. A tree fell over on Main Street in bumfuck Iowa. You're not going to see that unless you're zooming way in. It's not predictable. You couldn't predict when that tree was going to fall, Other problems you can only see if you zoom way out. Like if every bolt that was manufactured in 1982 is rusting twice as fast. Some problems are only visible like in large patterns like that. And then there's everything in between. And as a result, we're going from an era where most problems were known, right? You would build a system, you'd monitor it, it would fail periodically for a while. Every time you'd add monitoring checks, you're gathering up a corpus of information about how the system is likely to fail. And very rarely does anything really stump you, right? Like once or twice a year, it'd be like, oh, fuck, all hands on deck. We've never seen this before. It's probably your network settings. That world is kind of a relic. We're moving from a world where most problems were known unknowns to a world where most problems, if you've done your jobs well, are unknown unknowns, where every time you get paged, you're like, what's this? Right? Every time you get paged and you know what it is, you fucking fix it, and you automate it away so that it heals itself, right? This is somewhat aspirational, but you get my drift. We're moving into a world where unknown unknowns are way more dominant. This is driven by all kinds of things, like Moore's Law, the increasing maturity and sophistication of users demanding greater features, the platformification of so many products. I think of platforms as being when you're inviting all the users' chaos to come live at your house. And we're choosing to do this to ourselves. I don't know. Anyway, Hall says volume, blah, blah, blah. I'm a dropout music major, so I just drew this graph. It's going up, and you can see by my calculations, soon it will be impossible. This is because we're all distributed systems engineers now. And when you think that your system is up and healthy, it means that your tools are not good enough. Your system is never up. It's never up. Many catastrophic states exist all the time. You know how you put someone on call for the first time and you see it go, oh, there's an error. There's an error on the wall. But we should fix it. And you're just like, oh, grasshopper. But that good feeling that you get when you look at your wall of green graphs and you're like, everything's alive, it's false. It's a lie. And that's fine. It's fine, is the moral of the story. It's fine. You should invest in quality insofar as it makes a business difference for you. And you should just make your peace with the rest of it. It's way better than trying to fool yourself and thinking that they don't exist. We're all distributed systems engineers. Also, I believe this means we should all get a raise. Just saying. And the unknown unknowns outstrip the knowns. And distributed systems are especially hostile to the idea of being cloned or maintained. Like, if you were working on Facebook, would it be a good idea to clone Facebook and try to mimic its concurrency, its global geo-distribution? Like, you can see how ridiculous this idea is. No, nobody's going to pay for that. Like, they're not going to try and spin up a copy of Facebook to test every change. Yes, they have more money than God, but that's just not a good use of it. Instead, they invest in the tools that let thousands of engineers and their interns safely deploy to production. And they do not assume that nothing bad will ever get rolled out. They assume that lots of things that are bad will get rolled out, so they should invest in finding those things quickly. Everyone does this. Everyone who is fortunate enough to outgrow the idea that this is a tractable problem to solve with staging. Like the gold standard of testing is what? It's capture replay, right? I've built some of these before. They're super fun. Travis has built some of these before. That Travis. Right, they're fun. It's fun to capture everything that happens in production if your system is of the size that allows you to, and replay it and like tweak the number of concurrent clients and queries and try to get transactions right. It's super fun. And it makes you feel really good. And that is the gold standard, but you can only do that for components past a certain scale. And even then, like think about it this way, every single deploy of a particular version in a particular environment to a particular set of hosts or nodes or whatever is a test. You cannot actually test it before you do it. Think of all the times that you have misspelled production and added a K in there or something. That was a test. You failed. So what do you test in production? What do you test in staging? Like, some people, a very few number of brave souls who are my heroes, have just trashed staging altogether. They're just like, YOLO. My hat is off to them. Most of us are not quite that brave, foolhardy, whatever. We haven't done it yet. So we should think about what belongs in staging, what belongs in production. Oh, the other thing about distributed systems is that they basically just have this infinitely long, thin table of things that almost never happen except for one time they do. And good luck catching any of those in staging, right? It's things that happen one in a million times when like the stars happen to align and 3 bugs all happen at once. Yeah, black hole for engineering time. So what do you test before prod and what do you test in prod? Well, before prod, your known unknowns, right? I think of monitoring as being unit tests for operations, right? Every time you've found a way that your system or your code can fail, you write a test for it. You write a check for it. You do something to validate it because you know that you're going to forget, right? And you know that you want to find it more quickly the next time. You want to find it earlier in its life. Test all those things. This is table stakes. Test in prod. And by the way, a clue for trying to get very nervous manager and executive types to agree to this is just replace the word test with experiment. Things that you have to test in prod, besides the unique combination of deployed environment and tools. Well, behavioral stuff, right? A/B testing, classic. Got to be done in prod. How much good would it do you to run A/B testing in staging? It's just silly. Load tests. Like, you can do offline artificial load tests, but I actually really like a thing that I heard that a couple people do, which is they run just a 20% constant load test against production, because then you always have 20% headroom. It's great, right? It's brilliant. And it's a really good way of like validating for you, to your own mind that your shit actually works. Edge cases, like the things that, there are so many things that are only ever going to pop up with edge cases, whether that's a customer or a single node or a database query. I've seen people sink weeks into trying to reproduce these bugs instead of just having the tooling to go and look at it when it inevitably happens once or twice a day in prod. Canaries. Canaries are one of the biggest tools that you can do to gain confidence in your production stuff. These are complementary, right? What happens when, and you know the answer. You can write something for it. But there's this growing fast bunch of conditions and possible states you can get into that you just can't predict. So, like I said, every deploy to production is a test of that unique combination. That's fine. Sometimes you typo. It's fine. Also, remember, deploy scripts are production code. I think that we, even if you're, yes, this means if you're running Capistrano, that is in production. I'm sorry, that was mean. Here's the canonical best practices for canaries. It's a rolling set of, so Facebook does this by, I don't know why, but they always deploy to Brazil first. I don't know what the fuck Brazil ever did to them. But they deploy to Brazil for like 1% of users, and they watch it for a while. Well, they don't watch it, they have their robots watch it for a while, and then you promote it to 10%, 100%, and then they start, programmatically increasing that. And it's kind of amazing how little we as an industry have invested into deploy tools, period. Do you know, Travis, TMC, do you know of any open source like canary tools? Somebody should really write one. Somebody should start a company. Fix deployments for the world. I would give you my money. You can always have the robots do the first check, right? For all of your known unknowns in prod. I also think that it is increasingly mandatory for software engineers to have the muscle memory of when you ship something to prod, you go and look at it. Did what you expected to happen actually happen? Does anything else look weird? I think that we're going to look back in a couple years and just be flabbergasted at the amount of time that we spent shipping things and waiting to get paged. Like, seriously. It's usually right there, just kind of staring at you, but we don't look at it. And to be fair, we haven't looked at it because we have had shit tools. But if you're using Honeycomb, then you can absolutely look at it. It should be muscle memory. It should be habit. And I believe that this is usually not hard. You have to like twist some arms to get people to do it once or twice, but you will get hooked on the dopamine hit of just like finding things before customers complain, before alarms go off, before anything happens. You find it and you fix it. It's great. Staging is not production. If you're trying to keep your staging in sync with production, just stop now. Tell your boss I said to. It's fine. How many people who have staging environments are even monitoring them correctly? Almost zero. And I understand why we cling to this. It's this illusion of control that we can stop bad things from happening. We couldn't stop Trump from getting elected. We can't stop this from happening either. Also, like I said, there's diminishing returns from this. And Katie McCaffrey actually gave a talk at Papers We Love a year or two ago, where she presented on this academic paper where they mathematically proved, don't ask me how, that like 80% of the 80% of the bugs that we catch are caught by like 20% of the tests. You can predict a certain number of failures will happen as you're writing the code and you write the tests, and then things will break and you add tests for those things. Like, don't sweat it other than that. Invest that effort instead into production. Here are some things that you can do to make deploying to production more safe. Feature flags are the shit. They are so cool. Raise your hand if you're using feature flags. Yes! Ooh, they're the best. Launch Darkly is really great. One of the reasons that people haven't had the ability to go look at the things they deployed is because they haven't had tools that allow you to do really basic things like breakdown by build ID. Because high cardinality, wah, wah, wah. Do canaries, even just a dumb, simple one that like deploys 10% of your host, sleeps for 5 minutes, and then deploys to the rest. If those 10% go down, you can monitor them, right? You're still going to be way ahead of the game. Just, I'm not going to name names, but some large, successful unicorns in this city still deploy all their Java WAR files to production at once. At once. And they have reputation for going down a bunch. I have no idea why. Shadow systems are terrific, especially if you're rolling out really, really tricky things like rewrites. You can talk to any ex-parse engineer about those if you need to. And like the closer you get to the storage layer, the more paranoid you have to be. Because the more your mistakes are permanent and can actually ruin your business, take you out of business. So, do capture replay there, the closer you get to the storage systems. Not all failures are created equal. But failure is not rare. The good thing is, whatever code you write to test your guardrails, you're going to get tested a lot, because it's going to fail a lot. Things are going to fail a lot, and it will test your code a lot. That was my optimistic spin on it. But it's good because it's good practice, right? I believe that every engineer who commits code to production should know how to get it back to a known good state before they go escalate and ask for help. I believe every engineer who has the ability to submit code to the repo should know how to deploy their own code. Your users should not actually notice when any of your failures happen. If you feel scared to practice in production, if you feel terrified to impact your users, either you need a lot more tooling, not a little more tooling, or you kind of just need to bite the bullet and get over it. I've seen amazing engineers who build beautiful systems who are just terrified to touch production. And I don't really understand it, but we don't have to psychoanalyze them. We just have to push them into doing it because it will wear them down. It worked for me. Failure is when, not if, lots and lots and lots of whens. So everyone on your team should know what normal looks like. It's terrible if you're only looking at the system when it's in a broken state. You're going to lack that gut instinct, that visceral sense of something's wrong, if you don't know what something's right looks like. Everyone should know how to deploy, how to roll back, how to canary, how to debug their code in production. This, to me, is a very minimal, reasonable bar for what it means to be a senior engineer. I'm a big fan of asking these sorts of OPSI questions in your interview process for software engineers. Not because you necessarily expect them to know all the answers, but because you're signaling these skill sets are valued here, like from day one. These skill sets are valued, they are expected, they are normal, and if you join us, you'll learn them. So, I feel like release engineering is a systematically underinvested in skill in every company I know of more than 50 people. Your deploys are because of nearly all your system's failures. And just give up on the life goal of keeping staging in sync with production. Just give up. It feels great. So I would say instead of this, we should fight back with a slightly less catchy this. Or maybe this. Roar. Like once upon a time, these were optional skills. Not anymore. Distributed systems mean that operations engineering is very much a first-class citizen of every effective engineer skill set. And buy tools. Like you do not have to be the world expert in feature flags or observability. You can use a tool that someone else has thought about way more than you, instead of hiring way more engineers, because talent is incredibly scarce. Yeah, like so when a request comes in the front door and it hits like an application node, you actually have a node in front of the application node that forks the request to say if you're, hypothetically, if you're rewriting from Ruby to Go, it sends a request to both of them and returns the result from the known good mature one, and then it diffs the responses. And then you could at some point flip it over to return it from the new one, and again, diff, just to validate it. You can also get super sophisticated and have different copies of the data, but that starts to get super hard. Since we wrote that janky ass shit, Buoyant, I think, does this pretty well. Some of the new service mesh stuff I've seen talk. Do you guys know anything more about this? Istio and them. I've read some stuff. I don't think it's exactly like that, but they support this sort of shadowing. Thanks.